Not all stars are like our sun, some are stranger than science fiction. When we look up, we see a sky full of distant suns, each one unique. Our sun is just one type, but the universe is filled with stars that defy our expectations. Imagine a star spinning faster than a blender, or one so huge it could swallow Saturn's orbit. These aren't just ideas, they're real, and astronomers have found them. Join me as we explore 7 of the strangest stars in the universe. Prepare to have your mind expanded as we uncover the secrets of these stellar oddities. Our first stop, pulsars, the cosmic lighthouses. Picture a collapsed star, no bigger than a city, but heavier than our sun. Some of these neutron stars spin at incredible speeds, hundreds of times per second. They shoot beams of radiation from their poles, sweeping across space like a lighthouse. When these beams cross Earth, we see regular pulses, so precise, they rival atomic clocks. Jocelyn Bell Burnell discovered the first pulsar in 1967, and at first it seemed like a signal from aliens. But the truth was even stranger. A star spinning so fast its surface moves at a fraction of light speed. Pulsars are natural particle accelerators, cosmic clocks, and reminders of the violent deaths of massive stars. The Crab Nebula, for example, glows because of a young pulsar at its heart. These objects are engines of energy, shaping their surroundings with intense magnetic fields. Pulsars are the densest objects we can observe directly, spinning with mind-bending speed and precision. They're not signals from little green men, but they're no less extraordinary. Pulsars show us the extremes of physics and the cycle of stellar life and death. If pulsars are lighthouses, magnetars are cosmic monsters. Take a neutron star and crank its magnetic field up to a quadrillion times Earth's. Magnetars are the most magnetic objects ever discovered, so powerful they could erase credit cards from halfway to the moon. Their magnetic fields distort atoms and make normal chemistry impossible. Magnetars form when a supernova's chaos spins up a neutron star, creating a dynamo effect. This energy isn't stable, the crust cracks under stress, causing starquakes. These starquakes unleash bursts of X-rays and gamma rays, sometimes outshining the sun's output for 100,000 years in a fraction of a second. In 2004, a magnetar flare partially ionized Earth's atmosphere from 50,000 light-years away. Magnetars are rare, violent, and awe-inspiring, cosmic titans that unleash fury across the galaxy. They push the limits of what's possible in the universe. Their existence challenges our understanding of matter and magnetism. Magnetars are the ultimate extremes of stellar evolution. Now let's venture into the hypothetical quark stars. Imagine a neutron star collapsing so far that even neutrons break down into their building blocks, quarks. This would create a quark star, denser and smaller than a neutron star, made of a sea of free quarks. We haven't confirmed their existence, but some massive or fast-spinning pulsars could be candidates. Quark stars would be laboratories for the most extreme physics, testing the limits of quantum theory. If found, they'd reveal new secrets about the fundamental nature of matter. Somewhere out there, the universe might hide these exotic alien stars. It's a tantalizing possibility that keeps scientists searching. Now from the tiny and dense to the truly gigantic hypergiants. These stars dwarf our sun. UI Scuti, for example, would engulf Jupiter's orbit. Hypergiants shine millions of times brighter than the sun, but burn out in just a few million years. Their size makes them unstable, with powerful winds shedding mass and creating beautiful nebulae. Eta Carinae, a luminous blue variable, has sculpted the homunculus nebula from its eruptions. Living near a hypergiant would be impossible. The radiation is lethal. When they die, hypergiants explode as hypernovae, forging heavy elements and seeding new stars. Their brief violent lives shape galaxies. Hypergiants are cosmic architects, sculpting the universe on a grand scale. They remind us that the biggest stars live fast, die young, and change everything around them. Most stars aren't alone. Over half exist in pairs or groups. Binary stars orbit each other, and their interactions can get wild. As one star evolves, it can steal material from its partner, creating glowing bridges of gas. This mass transfer can make one star hotter and bluer, while the other becomes a stripped-down white dwarf. Sometimes the white dwarf pulls in so much material it explodes in a nova, or if it passes a critical mass, a type Ia supernova. These explosions are so bright, we use them to measure the universe. The dance of binary stars can end in spectacular destruction, visible across billions of light-years. Their interactions create some of the most dramatic events in the cosmos. In space, even stars can come back from the dead. Sometimes a white dwarf in a binary system explodes, but not completely. This partial supernova, called Type IX, leaves behind a battered remnant, a zombie star. These undead stars race through space, scarred by their own failed destruction. Astronomers have found these survivors moving fast and showing strange chemical signatures. Why do some stars survive while others are obliterated? The answer lies in the complex physics of stellar explosions. Zombie stars blur the line between life and death, challenging our understanding of stellar evolution. They're cosmic survivors, ghosts wandering the galaxy. Our final stop, Tabby's star, the most mysterious of all. This ordinary-looking star dims in bizarre, unpredictable ways, sometimes by as much as 22%. Planets can't explain it, neither can comets, dust, or stellar activity. The dips are irregular, lasting days or weeks with no clear pattern. Some suggest a swarm of comets, but the numbers required are staggering. Others propose debris from a planetary collision or interstellar dust. But none of these ideas fit all the data. The most famous theory? An alien megastructure, like a Dyson swarm, blocking the light. There's no evidence for this, but the mystery remains unsolved. Tabby's star keeps astronomers guessing, reminding us how much we still don't know. It's a cosmic puzzle, and the answer could change our understanding of the universe. Sometimes the strangest stars are the ones we can't explain. From pulsars to magnetars, quark stars to hypergiants, binaries to zombie stars, and the enigma of Tabby's star, we've seen the universe's wildest wonders. Each strange star is a chapter in the cosmic story, pushing the limits of physics and imagination. They're not just curiosities, they're laboratories for extreme science. These stars drive us to build better telescopes and keep searching the skies. For every mystery we solve, new ones appear. The universe is alive, evolving, and full of surprises. The strangest discoveries may still be waiting, hidden in the darkness, ready for us to find.